Hello, my name is Ryan Weiss. I'm with Integrity Assessment Group, and we're here at the Idaho Cleanup Project, demoing our robotic ultrasound inspection of drums. So this is the drum UT inspection. We got the mic back there, the operator. He just took a barcode scan, which fed the barcode into our tracker. And now he's taking two pictures, one of the bar scan tag, and then one of where the seam is located on the stand. The reason that we want to know where the seam is on the stand is for correlating data back from the scan to real life if we needed to go find an area, just correlation. And then he's going to start initiating the robot arm. And the robot arm is going to go over a cutout section as a reference for what's known as good material. And now the arm is going to pivot to the starting location of the bottom of the drum. And that's whenever we'll start collecting data of the actual drum to see if there's any wall loss. We're looking at the wall thickness of the drum. The drum nominal wall thickness is 0.058, 0.057 range. And you'll see the data is now being populated on the C-scan or the overview. The robot has just indexed and now scanning back in the other direction, and the robot will continue this process, indexing down and scanning, indexing down and scanning, building the data representation of the C-scan. The full session from the time that the drum is set down to the time that we're ready to say whether it's good or bad is 14 minutes. And we can approximate about 6 minutes for just the bottom of the scan. There's a 24-inch diameter on the bottom of this drum that we are covering 98.5%. We are using a closed loop water system, so we are catching the water that we are using and recycling it and reusing it. Total system is holding 3 gallons at the moment. So now you see we have completed the bottom scan of the drum, and we are moving to what we have predefined as side 1. And the side 1 scan takes approximately about a minute. We're just getting coverage in the areas where we're allowed to move the robot in between those posts. Now side 1 has been completed. The robot is now maneuvering over to side 2. And again, side 2 will take about a minute once the scan is initiated. We now see the robot positioning over to side 3. And as you can see, the robot has to make multiple movements to be able to position itself to where we can get the max amount of coverage within the limitations of the post of the stand. Now that the robot has positioned itself on side 3, the operator is initiating this scan for side 3, and it will take approximately a minute. The robot is now positioning itself to side 4. This will be the final side, and this scan will be about 45 seconds, and it's less time because, as you can see, the robot arm is now fully extended all the way out from where it's located on the base of the stand. So we have more limitations here being fully extended. Side 4 scan has now been completed. The robot's going to position itself back to the cutout reference piece and do what we call a reference scan out to confirm that nothing has changed from the beginning to the end. Operator has initiated the scan. Scan is complete, and now the operator is going to save the data and analyze the data in real time. This data is showing that there's no indications that show signs of wall thinning, so this drum would be considered as passed, and we'd move on to the next production drum.